Okay, cool. Looks like I can go live on both. Wait. Okay, what should we work on? Well, we should post something, right? What should we post? We got no requests. Let's see. What should we post? Pre-calc, regular, first year calc, or should we do a vector calc? Should we do a vector calc first? Yeah, let's post something from our... Okay. Let's see. Maybe we'll do this one. Think there's enough space on the Blackboard one? Possibly. What are we doing? 2.5? Vector calc 2.5. I need my stand. We are going to do chain rule of some compositions. Okay. What should I write? What is the derivative of FOC? Might be in a shorter form. Oh, a tea's boiling. BRB. Okay. Close the door. In my notes, I didn't really write it the proper way, so I'm thinking, what should I do to make it look like a regular question? Sure. F-O... Yeah, let's just do it called FOC. Or the composition of F and C. Okay, so f of xy is equal to x squared plus y squared. Hey, Simon hosting with 3 viewers. Welcome, buds. Hey, Mostly Panda. Thanks for the follow. Log of the square root of x squared plus y squared. And then c of t is equal to e to the t comma e to the minus t. Okay. I am just getting prepared to post a question to Instagram. This is just one that I've got notes for, and I'll just do it and post it. Then we will go and we'll do like literal tutoring, regular stuff. Probably start with pre-calculus or just do first year universities type stuff. Maybe we'll do calculus. I'm not sure. No, I don't really have any requests right now, so we'll see. Also, this is the first time I'm broadcasting to both Twitch and YouTube. I've never tried it before. I'm wondering if it'll make it so that we'll see more people. Okay, so we got to use the chain rule. So the derivative of f with respect to t is equal to partial of f with respect to x times the partial of x with respect to t plus, and I should make this look as nice as possible, of f with respect to y, and then times the partial of y with respect to t. Okay. What is the first derivative? Okay, so we've got x squared plus y squared times log of x squared plus y squared square root. This is actually natural log. Maybe I should write natural log. It's just that this textbook actually uses natural log, and then that'll look better. Okay, what's the first derivative? We got partial of f with respect to x. So x is our variable, so that means y stays constant, so we don't have to worry about differentiating y. So this is a product rule. So we'll have to go x squared times natural log of blah blah blah, and we'll split it up into two. So let's do this over here. I'm gonna just scroll down. This was our tutoring that I did earlier for a kid. And let's write it out in here. X, well, I guess I need to change color. X squared plus y squared multiplied by the ln of the square root of x squared plus y squared. We want to take the derivative of this with respect to x. Product rule is fg prime plus gf prime, which means we have to have, or is it f prime? I always mix up this order. I think that's the one for f prime g plus g f prime, or f prime g plus f g prime. There we go. So we need the derivative of the first part, so this will be f and this will be g. Derivative of the first, so in this case x squared is the only thing, and then the derivative of y squared, it's a constant, so it'll be 0. So we'll have 2x. And then g, which is ln square root of x squared plus y squared. And then we're going to add. Now we've got x squared plus y squared. And then we're going to have the derivative of the natural log function. Derivative of the natural log is 1 over what's inside it. So we're going to write this underneath here. Square root of x squared plus y squared. Then we need the derivative of the inside, which will be, well, this is quite a few parts. If I split it up, this will be x squared plus y squared to the 1/2 is what this actually looks like, right? And if we take the derivative of this, the 1/2 will come down, 1 over 2 times this x squared plus y squared minus 1, so this will be minus 1, then multiplied on by the derivative of the inside with respect to x, which is just 2x again, so 2x. 2's will cancel out. And this means it's a negative exponent, so it'll be on the bottom. So this is what we'll have now. So if I write this 1 over 2, and then 2x on the top, and I'm just going to write it this way, and then it shows everything canceling. And then I'm going to write this as a radical again. We've got the square root of x squared plus y squared. And now the 2's will cancel. And then we got one more thing that'll cancel, which is interesting. And that is the fact that square root of x squared plus y squared times the square root of x squared plus y squared. Remember there, it's 1/2 and 1/2. When you multiply, the exponents add. 1/2 plus 1/2 equals 1. So this becomes just x squared plus y squared on the bottom. So then this is 2x ln of square root of x squared plus y squared plus x squared plus y squared over x squared plus y squared. And then there's an x still up top, which I'll just write over here. So these will cancel. So then this is just 2x natural log of square root of x squared plus y squared plus x. Okay. Now what? This is our derivative that we need to write in here. That's just the derivative of f with respect to x. So we've got, and I'll write it in brackets. So I need to change colors again. Okay. 2x ln of, well, the square root, right? You gotta write that in there. Square root of x squared plus y squared. And then we're going to add x. Okay, and now the second part. What is the derivative of x, which is the first component with respect to t? Derivative of e to the t is just e to the t. And this is just multiplied by e to the t. Now the second one, which I'll write the addition sign down here because it's going to be big again. So now we have to do the same derivative, but now with respect to y. So what's that going to give us? It's going to give us the same thing, except for y is now the exponent, or the variable that we work with. So then we have 2y natural log of the square root of x squared plus y squared plus y. Now we have to find the derivative of the y component of c with respect to t, which is negative e to the negative t. Negative e to the negative t. And I'll write an equal sign here. Good. Then we need to multiply it all out, simplify it, and how am I going to write this? We got to sub in the e to the t and the e to the minus t for the x and y values. So let's sub it in now. We're going to have 2, and instead of x, we have e to the t. And we have natural log of the square root e So this is x squared, so e to the t squared, which is e to the 2t. E to the 2t. And then plus, it's going to be y this time, so e to the negative 2t. And we're going to close the bracket, plus x, which is e to the t. And then we're going to multiply all of this by e to the t. And then we're going to add the second line. Now we've got y in, so we're going to write bracket 2 e to the minus t for y, natural log square root of x squared, which is e to the 2t, plus y squared, e to the minus 2t, close the bracket, plus y this time, which is e to the minus 2, which is minus t, right? And then close it, and then we multiply by e to the t. How many lines do we have left? One, two, and then maybe three. Can we simplify it down? Let's see. What line can I skip? I'm gonna skip this line and then go straight to e to the 2t times the 2 ln of square root e to the 2t plus e to the minus 2t 1 . And can I write this one in there? It's gonna be tight. Minus e to the minus 2t times the natural log of e to the 2t. Oh, maybe I should write in it that I skipped steps so that you can work through it. There's still gonna be a 2 here, so maybe I won't skip that far. Yeah, okay. Plus e to the minus 2t square root plus 1. And then I'll show you over here. So log rules, we have 2. I think I should switch back. We should have 2 natural log. Oops, that looks like an H. Natural log of the square root of x squared plus y squared. We'll do it this way. Even though it looks different on the slide that we'll post, it's the same thing. When you have a number in front of a log, this is equal to the natural log of number brought up into a square. So it goes up. And in the same way, you can bring it down. So if you're going to go the other way. So this is the natural log of square root of x squared plus y squared squared. And when you write this as a fraction instead of a radical, so then you have the natural log of x squared plus y squared to the 1/2 now multiplied by a 2. So then this 2's cancel out and becomes a 1, so you're left with natural log of x squared plus y squared. Which is what we're going to use here. So these, undo, I need to change colors again. Smart people on this planet. There is no smart people. What are you talking about? We're humans. Humans aren't smart. And I'm just doing this one to post on Instagram. I'll do the regular calculus right after this. Or, I don't know, grade 12 or something. Doesn't matter. I've got everything from grade 9 to first year university ready. Okay. Now, we can simplify this to get the answer. Since these will become the log of the x squared plus y squared, I can then break it up into 2 pieces. So these two are the same, if you've noticed. That means we've got e to the 2t minus e to the minus 2t in one bracket. So these two come out, and then we can multiply that onto the remainder, which will be natural log of e to the 2t plus e to the minus 2t. And I guess I don't need that bracket. Maybe I should make it look a little nicer. Natural log of e to the 2t and plus e to the minus 2. Yeah, looks like my notes. Honestly, why I quit my job? This was a while ago. I've been technically jobless since January of 2017. And Robbie, I had massive depression because I was a financial advisor in a bank and it was not good for me. Really not good for me. I knew I was missing a 1 somewhere. I must have missed it in my notes when I was writing. I'm gonna write it big bracket. There we go. The log of e to the 2t plus e to the minus 2t. I was missing this 1 on my notes for some reason. Plus 1. Done. There we go. That's better. Honestly, I live in Canada. There is no Wall Street up here, especially when I'm in Saskatchewan, not Toronto. Okay. Let's see. Good enough. Let's post it. The Dominator. Welcome back. Okay. We're just gonna quickly save this one, so I'll post it on Instagram. And then we'll do regular stuff. What should I call this? Vector composition derivative? Probably. Okay. Keep doing that stuff. What should we do now? What do you guys think I should do? Should I... That's okay. What's a good... Okay. What do you guys do in your normal lives? So the funny thing about math is the logic behind it stays the same, and it can be used in your regular lives. So I used to be a financial advisor, right? And the main problem that people had is they spent too much money, and they needed to know how they were going to pay off their debt. And what made more sense, to pay off their mortgage or pay off their credit card or whatever. And it needed to come down to, what was your time frame? Not so much how much money you had available to pay things down. It's just, what was your time frame? What were your goals? What were you working on, right? And when it comes to math, you can use the same logic to your regular life. So let's see. Honestly, I live in a small city in the middle of Saskatchewan. And I say small, it's like the biggest city in Saskatchewan, but it's small compared to pretty much every city elsewhere. There's not a whole lot of jobs here for people like me, I guess. And truth be told, I don't really know what I like doing yet. So far it's just this. Work out every day and see if I can do some math and teach some people. I tutor a kid every day before I stream, actually. I keep telling him that I want to actually stream it to see if I can get more people. But he's pretty busy, so I don't want to make it any awkward for him. And I tutor him just online like this. I just screen share in Discord and he helps. Funny story. I was dating a girl a while ago. He ended up moving to Toronto, and he's now a major marketer for cryptocurrencies. And she just does like interviews, and she's huge in the cryptocurrency now. Because I always just contact her and say, hey, what do I have to do? But no, I don't think so. I really don't know too much about cryptocurrencies. I'm not really interested. To be fair, I'm not really interested in any of the markets. You know, I'm like that academic that never became an academic. Let's see. You'd think. But the problem is I'd have to go back to school and learn those other things. Yeah, there are pretty awesome predictive models. Like we did, jeez. Remember, I did combinatorics, I did differential equations. The physics stuff was more interesting. Oh, okay. Let's see, what should I do? thinking. Man, okay. What is relative to regular day life? Now you guys are talking about like cryptocurrencies. What kind of math stuff is relative to that? What's simple math that could be relative? Slopes, fractals. If it were only that easy. If it were. I'm gonna be right back. I just need 2 seconds. Got a tea bag here that I want to get rid of. Okay. Fields medal. Do you know how smart you have to be to get a Fields medal? Have you ever heard of, geez, what was his name? Actually, have you guys ever seen Numberphile? It's a YouTube channel. And what was it? Hardest question? Terrence Tao, yeah. What was it? There was question 6. That's what it was. The Legend of Question 6. Let's see. Very few people got it right, and it was something that you needed to... It's like A and B be positive integers such that, and then there's a little formula. Guy from your country did it? Well, and he won a Fields medal. Solve the problems that Einstein couldn't solve. The problem with doing advanced stuff is you need money to live. I don't exactly have that. I pretty much lost everything. And I had stomach ulcers, which caused me to not be able to even sit up for like a year. And I'd have super huge anxiety and stomach problems. It was not fun. But I should just start with tutoring kids in university and in high school. Make some money. Maybe this can get big enough to warrant keep doing it. Okay. Pre-calc. What's relative to people these days? Functions? Actually, getting a teaching assistant position. Honestly, I applied for university to go back to go do teaching degree, but they put me on the waiting list, and they said that I'd be on the waiting list until the day classes started. And if I hadn't heard anything till then I didn't get in. And that was months ago. So I don't think I'm getting in since classes will start soon. Which means I gotta figure out what I'm gonna do. I already have 2 degrees. And basically they're just pieces of paper. What is the problem that people face when it comes to algebra? They are scared of this symbol. Yeah, I have 2 degrees. I first got a math degree and then I finished it. I had a job with the bank as a teller, part-time. And then a month later, I went back and started a finance degree. Year later, I was supervisor at the bank and a year done with a degree. Second year later, I was manager and finishing my degree. And then within months, I had a third job at the bank, and that was it. I think I had 5 different positions. 4 different positions. 1, 2, 3, 5 different positions in 4 years in the bank. So I actually find the people have a problem with just what it means by a variable. So let's say this is our function. Big deal. And then you say, what is f of 2? And then people are confused. Then I'm always like, why are you confused? You just plug in 2 for x. Or what's f of x plus 2? That's when they get even more confused. They don't know what to do. So what I like to do is search up a cartoon. What's a cartoon character that's well known, let's say? Homer Simpson? Can I get just a small picture of him? Maybe this will work. Ugh, it's huge. Okay. Homer Simpson is now our variable. Which means nothing, really. Can I copy and paste it? Yeah, kind of. Homer Simpson is going to be our variable. So, I can literally plug him in. And it makes no difference whatsoever. This is f of Homer Simpson. Doesn't matter. So it's going to be Homer Simpson squared. And where is my layer with him? I don't need that one. And duplicate. Give me half a second here. This is what people have problems with. They don't understand that you can plug in anything for a variable and it doesn't matter. It doesn't change anything. Actually, Lawrence Krauss was talking about what's the words he used? Defining something doesn't change how it interacts with the universe. So just because we have a number system, let's say 0 through 9, we can label these anything else we want and it'll still work and solve the same way as long as we have a translation. So we'll say 0 is 0 and we'll just do the rest as the Roman numerals. We got 1, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. It doesn't matter. As long as you have a way to go between them, you can change the way it is in any way. So this is like Homer Simpson plugged in as our variable. And this is just x as our variable. Now x plus 2 is our variable. Is just change what this looks like to be what this looks like. It really doesn't do anything. Alan Watts? Oh, right. I have that muted. That's why I would never notice. There we go. What does Alan Watts have on YouTube? I'll write it down. What does he talk about? Two times x plus 2 minus 1. Or what is f of v? F of v is v squared plus 2v minus 1. Well, that's pretty easy. What about when v is itself a function? So let's say it's v of t this time, which is e to the t. This is where people screw up. They don't know what to do in this case. Well, f of v is just f of v of t. So you just plug in your v of t for wherever there's an x in your original. So we've got e to the t squared. 2e to the t minus 1. Philosopher. What kind of concepts is he talking about? And I actually just had a test Monday. I had another breath test about it to see if the bacteria is gone. And I'm hoping good news. I have to wait 2 weeks for the results and then maybe I'll hear back from my doctor. Free math concepts. Interesting. Interesting. Also, I have a question for you guys. How does the stream actually look? Because I noticed before I was having difficulties with my internet and it would drop frames, and which is really weird because I should have max internet speed. And if you know who Alinity is, she's in my same city and she connects to the servers just fine. I don't see any problem with her stream. Okay. You know what? Let's do some calc. All right. I haven't done calc in a while, so let's just do some calc. First part or second part? Yeah, her only problem is content. I know what you mean. An exceptional speaker, you say? Okay. Should we do part 1 or part 2? Part 1 would be derivatives and limits. Part 2 would be integrals. What do you think? Actually, better question is, what background do you guys come from? Maybe I can work on some stuff that would be more relevant to you guys. Computer science. So you've probably done quite a bit of stuff with matrices, right? Arrays. Algorithms. Interesting. Interesting. Okay. What see, I don't really know what could be relative to. See, when I did linear algebra, the first linear algebra I didn't really care too much. It was just really easy, and everybody blew through it and had 80s or higher. Second linear algebra, we started with 16 people, which I thought was great because that seemed like a lot. Yeah, that's okay. Cool, bud. Yeah, let's chat. Linear algebra 2. Now, I'm sure you probably didn't have to take it because linear algebra 2 is like full-on theoretical, where we do infinite vector spaces. And we started with 16 and ended with 3. And I actually took the course twice because I was one of the people that left it the first time. And it was pretty bad. Those classes, you know, when 90% of the class drops out after the first day. Those are pretty funny. Let's see, what can be relative? Techniques for maybe finding patterns, slopes. Okay, let's play with some. Well, math is not for everyone, that's true, but most people don't know what real math is. The best thing I've ever heard is all through high school. Oh yeah, proving theorems is lame. I never really liked it either. Mostly because I sucked at proving theorems. I'm sorry. I was bad at it, okay? The best thing I ever heard is when somebody talked about Yeah. Best thing I ever heard was high school teaches you how to paint a fence. So you never actually understand what a painting looks like if all you've ever done is paint a fence. Because in art in high school, you can see beautiful music, you can see beautiful paintings, sculptures, all those things, and that's art. But in math, you can't really see the beautiful things until you get really deep into it. So in high school, everybody learns to hate math because all they ever do is just simple things over and over and over again. Like x plus 2 equals 3. I was tutoring a kid today that we've done absolute values for 3 days now. And the absolute values of like simple things. X plus 2 minus 1 is equal to 5, let's say. And we've done these for 3 days. First day we kind of did graphing them, like what's the vertex of... So he was given a formula. F of x is equal to a absolute value of x minus h. What was it, plus k? Yeah. And then you had to like learn each piece of the formula, but they never actually learned what the formula does, or even knowing that this is just like a shift and this is just a shift and this is could be a reflection if it's negative, but it's really just stretching. Like the kids in high school these days, they are shoved formulas before a concept. And I wonder why. When you guys learn something, do you learn a formula or do you learn a concept and then try and figure out the formula from it? Well, you'd think they don't need to, but it would be so much easier to learn a concept because then it applies to all their functions throughout their high school than learning a new formula, then learning a new formula, learning a new formula, and learning a new formula. Because remember, these things is just that new functions from old functions. Who works in a job that requires thinking? Depends. Are you dedicated to your job? Or are you getting paid? Because there's a difference between people. I was too dedicated to my job, I think, and that's what drove me nuts. Because it was the people that drove me nuts. Do you know how much wear and tear it can be on somebody when you meet them and they haven't even learned your name, but their preconceived notion is that they hate you? I went through that at least a couple times a week. Or sometimes 3 times a day. Like, yeah, however, it's the thinking that comes along with it. So, let's use this functions from old functions, right? We'll just do these things right here and talk about the thinking behind these. So we already know that this is a shift up. This is a shift down. This is a shift right. And this is a shift left. Okay, now what is the thinking behind this? These are general, right? These are general. They'll work for pretty much most functions, if not all of them. Yeah, I did this from an Instagram post. I just wrote them down as just something to post. I mean, I've had a few requests from people, especially on Instagram. Like, I get a message every once in a while. For like homework help, and they send me a picture of their homework, which is really good. I like it when people do that, because that means it's more engaging and whatnot. But I want to delve deeper into this concept of thinking, because this is right here adding a number and subtracting a number. And this is subtracting and adding a number, but it works differently in the operation. Now, there's a bunch of people in the average population that doesn't understand what happens when you add something to it. Not just a function, but let's say a bag of marbles. What happens if you have more marbles? Sometimes they'll not know what to say, or how to represent it, or how do you go from your original object to something new, and put it into words and to tell other people. So if we have let's say a ball, or maybe a little flower thing. Do a little flower. It's in our original position, and we want to talk about how it can be moved to be something new. I know this is completely weird and doesn't really make much sense, but I just want to kind of think about things. If we have some kind of base of understanding of where that position is, because maybe they have to translate it to somebody else. How are you going to translate a change in position to someone else? You got to think about how you move things left and right, how you move it up and down, how do you stretch it, how do you do any of those things? And that actually applies. Translation matrix. Yeah, but the general public doesn't know what a translation matrix is. I had one guy who's a med student send me a message that was just, tell me about the different types of matrices. And I asked him to be more specific. And he came back with, tell me about matrices. And literally, I went through like 4 times asking him to be a little bit more specific, because matrices is a big subject. I don't know what kind of stuff you're working on. Are you doing factorization? Are you doing multiplication, addition? Are you doing translations? Are you doing, like, what are you doing? And eventually, I was just like, screw it. I'm gonna just write, I don't know, the basic principles of a few basic matrices, like I posted on Instagram, and see what he has to send back. And what he sent back was the last one, and then he sent a message the next day was just to prove simple stuff. in which case you don't actually have to do anything. It was, he was given some matrix A, and some matrix B, and some matrix C. And he wanted me to literally show that A is B plus C is equal to A times B plus A times C. That was his question. I know, you can Google it. But there's nothing to Google here. You literally just add the two matrices and multiply by A, and then you multiply these two together and see if they're equal. Like, sometimes it's questionable. And also, you guys are on Twitch, right? Do you know how often I'll get a message and say, join me on Twitch and I'll help you? And they'll be like, what's Twitch? And I'm perfectly fine with saying it's just a normal website, kind of like YouTube. And they're scared because it's not YouTube. They're scared that it's Twitch and it's primarily gamers and whatnot. And they don't want to click the link because they think it might be some kind of spam or something. So even the general population doesn't really know about Twitch, provided, even though we have millions of people on here at a time, right? Interesting. Okay, going back. I want to talk about... What do I want to talk about? It'd be so much easier if we had someone to help with their homework. Yeah, definitely a hacker. Integration by parts? Did we do some integration by parts? Practice integration? Sure. I haven't done that in a while. So integration is the area under the curve, right? In computer science, you would use that a lot, wouldn't you? NA education platform answering multiple choice questions. Right. They have that these days. In university, when I took my calculus course, we still had a lab to do homework in. And it was literally hand-in sheet paper. I think it was like 4 or 5 questions. You'd have 3 hours to do them. And the year after, they switched to doing those multiple choice. And the problem with that, I found, was there's lots of people that'll have the right answer, but can't type it in the right way in the computer or the way they want it. Even if they type it in right, it still won't be correct the way the computer wants it. And so they'll lose like 20% of their mark because they can't type it in properly. Thought it should not be so specific. Those, I think it's on Blackboard. Is that what they do? Blackboard Learn? Okay. X squared natural log of x. And they want us to do this first. And v is equal to x squared. there are dedicated people out there that do their homework. And there are a lot of people out there that will be lost and confused doing their homework. So that's why I'm trying to do this. Lots of times those people doing those online questions, they'll be stuck, they'll be confused, and they'll be wanting help. Hopefully I can be around to answer. Okay. We're going to do this by integration by parts. We have to define what that would be. The integral of how did they write it? U dv, that's right. U dv is equal to uv minus the integral of v du. There. So we have u, and we need du. Derivative of the natural log is 1 over x dx. And dv is x squared, so v would be the integral of x squared, which would be x cubed over 3. And to plug it in. So we've got the integral of x squared and ln of x. I should say dx. The x cubed over 3, natural log of x, minus the integral of v, which will be x cubed over 3, and times du, which is 1 over x dx. I'm basically just kind of going through stuff that's integration under the assumption that I can go at a certain speed until somebody says they need help. And then I can go through specifically what they need help with. So if I go this far, now is when I can be like, okay, is this too far, too fast? What point are we missing? Because frankly, when you do math, you have to assume you work on a cheat sheet about integration tricks. The question is, what really is a integration trick? Sometimes the trick is actually going through the problem 3 times because of the integration will end up being a duplicate, and you can move it over to the left hand side and it'll be 2 of some integration and then solve it that way. Or right here, so what this is integration by parts. And integration by parts is, think about month 2 of second term, maybe 3 weeks into second term. I think it's like the second chapter. If I wanted to really kind of go through these things, we'd have to start at the beginning. If you guys were completely fresh. Should I assume that you're completely fresh? Since you guys are my audience right now, I should ask you, where or what knowledge do you have of calculus? This will cancel out, gives us x squared. What do the D's and long S means? Okay, see, that's a good thing to know. So you're completely fresh. Have you ever done any calculus before? Because if you haven't, then we got to start right at the beginning. Actually, we'd have to go, what does derivative mean? What does... Okay, I know you're okay, so you're kind of kidding. How far did you get in calc and what do you remember? Do you remember any integration or do you only remember maybe the first bit? Because basically I have to assume if nobody stops me, I have to assume everybody can keep up until this point. I'd start at the very beginning with what's a function, but I know, right? It's interesting to think about what you're trying when you're trying to teach it. Someone known doesn't know. I actually spent a lot of time this past 2 days maybe watching TED Talks about teachers. What makes a teacher better is teaching. Okay. Yeah, you're good then. The problem is right now, so you guys have done this stuff before, obviously well educated. Right now I can just kind of talk to you and there's no real issue. You're just hanging out. Problem is I need some actual person that needs help doing this. Unfortunately, classes haven't started yet. So I guess right now it's just practice. Although I do have a story about last year. So before I got sick with ulcers and stuff last year, it was in April. I think it was middle of April. I decided to try this, to turn on a stream. I had my whiteboard set up with 2 cameras and terrible lights, and there was a little bit of a glare on the whiteboard, and I just turned on the stream and I started streaming doing limits. And I just went through the textbook doing limits. And within an hour, I had within an hour, I had like 1 or 2 people. And then somebody, I don't remember who, asked if they could post it on Reddit. They would post a link or something. And it was cool, sure. And then a little bit later, somebody hosted for 13 viewers. It even still shows it on my Streamlabs. And by 3-hour mark, I had about 30 people on average, which was really great, but it was kind of unfortunate because it was midnight and I was already pretty tired. But it was really cool. It's kind of what inspired me to try this again. But it also was during final season, so lots of people were online looking for help. And then right after that, I kind of got sick, and that was not fun. Actually, can I ask you guys if have you guys ever looked at YouTube? Yeah, you too, but have fun. Or if it's nighttime, have a good night. Yeah, they were really looking for help, I guess. But it was interesting though, because the people I had, they weren't in classes. They weren't asking about it. There was one person who asked about some integral using polar coordinates, and all we did was have to set it up, and then he was like, "Great, I know it now." And that was it. Honestly, I don't even know really how to get to YouTube streaming. I know everybody's like, yeah, YouTube has this streaming thing just like Twitch, but if you go to the YouTube website, you have to really look for it. Yeah, Panda. The whole idea is to get noticed, right? So I'm wondering how people find live YouTube channels. But not as clean as other live streaming platforms. The only thing is people know YouTube. They're not scared of YouTube. The average population. Like, even my parents know what YouTube is. But if you say Twitch, they're like, what are you talking about? Anyways, so I can finish this problem. Might as well, right? X cubed over 3 natural log of x. That stays the same. Now the integral of x squared over 3. It's just the reverse power rule, so you have to bring the exponent up by 1 and divide by it. So 2 plus 1 is 3. 1 over 3 times 3 is 9. 1 over 9 x cubed. And then you would have to, of course, add a constant when you do integration. And that's it. Easy. Integration by parts. Now, of course, you could simplify it. I don't really care that much. You take an x cubed over 3 out, and then you'd have natural log of x minus 1 over 3, then plus c. But whatever. Let's just keep doing some integration by parts. Might as well. What is the integral? Actually, how far up did I go? See, I was doing these absolute values problems with a kid earlier. And honestly, they're the same thing over and over and over again. And yet they always need help with every new problem. Which means the teachers aren't teaching a concept, they're just teaching a formula. It's really unfortunate. Not every teacher, obviously. There are a lot of good teachers and dedicated teachers. I know because I had a really good math teacher. Actually, most of them were really good. Some of them in high school, they just did the math, but I understood it anyways because it was, I don't know. I thought, to me, the first stuff was always plain and simple. Now it doesn't seem like they get much into any details. Anyways, let's do this integral. Why am I having trouble with my slider today? Funny thing is, the YouTube streaming looks okay. I'm streaming both right now, actually. I'm not getting any drop frames, which is amazing. The internet must have fixed itself. Okay. How are we going to integrate this? It's integration by parts again. So I'll write the formula. Integral of u dv equals uv minus the integral of v du. And we're going to set u equal to r. Because I have a sneaking suspicion that this is going to make it easier. And I'm going to say dv is equal to e to the r over 2. Yeah. I'm going to take the derivative of u, so the derivative of u, so du equals derivative of r with respect to r is 1. So we've got dr. V, the integral of e to the r over 2, which would be 2e to the r over 2. Now I know that because if we take the derivative again, and the derivative of e to the x is just e to the x. So derivative of e to the x when it's got a constant, let's say, and you just bring down the constant over and over and over again. No big deal. Then we can write, I'm going to put this in as a note. Then we can write this integral is now equal to u v, so u and v. Remember to write the 2 first. 2r e to the r over 2. And we're going to minus the integral of v, which is 2 e to the r over 2, and du, which is dr. Not bad. Take the integral of e to the r over 2, so this will just be 4 e to the r over 2. And let's simplify. We'll take out a 2, and we've got r minus 2, and then e to the r over 2, plus some constant. Easy peasy. UED. Let's see. Another one. And another one. Let's try this one. E to the 2 theta sine 3 theta d theta. I don't know this off the top of my head, so let's figure it out. What can we do? We're going to do integration by parts again. It's the same concept. So we've got the integral of u dv is equal to uv minus the integral of v du. What do we set as u and v, or u dv? U equals and dv. What do you guys think? What should we set u equal, and what do you think we should set dv to? And give me 30 seconds while I look for my reference pages. I actually tore out the reference pages from inside my old textbook and I carry them. Because they do make a difference. Okay, let's do u as e to the 2 theta, and dv is sine of 3 theta d theta. Then we're going to take the derivative of u, which will be, well, you're going to bring the 2 down, so 2e to the 2 theta d theta. And the integral of sine is what? So derivative of cos is minus sine, derivative of sine is cos. So we've got a minus 1/3 cos 3 theta. Because derivative of cos is, did I say it right? I feel like I said it wrong now. Yeah, derivative of cos is minus sine. Right, I did it right. So then the negatives will cancel out, the 3's will cancel out, and you'll get sine 3 theta. Perfect. Now let's try it. We got e to the 2 theta sine 3 theta d theta is equal to uv, which is e to the 2 theta, and v, which is minus 1/3 cos 3 theta. And we're going to minus the integral of v du. We get a minus times a minus. We're going to just simplify it out right away. We've got cos 3 theta and du. We're going to have a 2/3. I'm going to write it out front because the constant can just come on front of a integral sign. We've got e to the 2 theta cos of 3 theta d theta. It doesn't look any better. We're gonna have to do it again. Let's try it again. I'm gonna call it u prime is equal to e to the 2 theta and dv prime. And prime just means something that's different. That's all that I'm using to say it. I could have used different letters, but I feel like that might be a little bit confusing when we go and reuse the formula. So d prime and u prime would be 2e to the 2 theta. Theta. just like before. And now we've got v prime is the cos of 3 theta d theta. And what's the integral of that? So 1 over 3, just like last time. No minus sign this time. Sine of 3 theta. Now this problem is one of those tricks that we were talking about before, where we're doing it over and over again, and we'll see what happens. So I'm gonna write the whole thing out though. We've got this line. The integral of e to the 2 theta sine 3 theta d theta. Hey, why, thank you. Welcome to the group. We're gonna make this, so this stays the same, e to the 2 theta cos of 3 theta. And I'm gonna write a plus 2/3, and then I'm gonna have a big bracket, because now we're gonna do it again. We're doing this integral. So u times v, 1/3 e to the 2 theta sine of 3 theta. And if it's too fast, just let me know and I can re-explain. And then we've got a minus, and we've got another integral. And what is it this time? V prime, so 1/3, and there's a 2/3, 2 over 3, so we're just gonna go 2 over 3 e to the 2 theta sine 3 theta d theta. But this one looks the same as this one. Now we're going in circles. So is that where we just end off and we're going in circles forever, or do we mess with something? Let's try messing with something. So I'm gonna write this down, same as before. But now I'm gonna distribute the 2/3. So this would be 2/3 times 1/3, which is 2 over 9. E to the 2 theta sine of 3 theta. And 2/3 times 2/3, and this is a minus 4 over 9. And this is still multiplied by the integral of e to the 2 theta sine 3 theta d theta. And this side is still e to the 2 theta sine 3 theta d theta. Okay. Well, they're the same. They look the exact same. There's just a number in front of this one. So just like any other, let's say, line solving, you could say this is just x equals negative 1/3 some number, is different, and then minus 4 over 9x. So we could take this to the other side. We'll see. We'll add them together. So if we take this over, this would be the integral. And now I'll draw my screen down so everyone can see. E to the 2 theta sine of 3 theta d theta. Bring this over. 4 over 9. It becomes positive, and so you add it, so plus 4 over 9 as the integral of e to the 2 theta sine 3 theta equals, and then what we still have left negative 1/3 e to the 2 theta cos 3 theta, and plus 2 over 9 e to the 2 theta sine 3 theta. And now I'm going to get rid of this just for clericals. So we add them together. So 1 is the same as 9 over 9. 9 plus 4 is 13. So we've got 13 over 9 times the integral of e to the 2 theta sine 3 theta d theta is equal to negative 1/3 e to the 2 theta cos of 3 theta plus 2 over 9 e to the 2 theta sine 3 theta. And now you just get rid of the 13 over 9. So this integral from the beginning, e to the 2 theta sine of 3 theta d theta, is now equal to 9 over 13 times all the rest of this mess. And I'm just going to reverse these orders so that it's a positive minus a negative, not a negative first. So we've got 2 over 9 e to the 2 theta sine 3 theta minus 1 over 3 e to the 2 theta cos of 3. And then you can just simplify it out. So the 9's cancel out, so we got 2 over 13 e to the 2 theta sine 3 theta. And 9 and the 3, so that's just going to be a minus 3 over 13 e to the 2 theta cos 3 theta. And you can simplify it even more. How should we write it? Sine 3 theta minus cos 3 theta over 13. Oh, I forgot to add in the numbers. Silly brains. 2 sine minus 3 cos e to the 2 theta. And then you've got to add a constant. And that's probably the answer, unless I screwed something up. Nope. That's all that work. There's the beginning of the question at the top of the screen. Right here. And we did all that work for one integral. Look race. Look race. It's a bit too big to post in a simple Instagram post. I mean, I could write it out on one whole page in a nice way and just take a picture of it, I guess. But that wouldn't be the same as doing post-it notes. Quick tidbits of information. Because this was a quick one, even though it was really long. But a post-it note doesn't have that much space. What other things can I do for post-it notes? I wonder. Let's see. What other things can we post? While we think about that, I am going to actually do the Instagram post. Because I never did. I don't like how you can't just post from your computer, though. Mwahaha. What do you guys think we should do? More integration by parts? Maybe play with functions? Does this honestly say run an ad break? We're not gonna do that. I'm not even monetized. Why would it even give me that? It's not cool. Let's see. Special name rule. Good enough. Let's see. Let's see. Actually, here's one that's fun. Funny short clip from Alan Lott's video. Okay, let's see this. I'm gonna mute it on stream. I'll watch it while we work on the next bit. Because I've gotten this idea. How do you find the derivative of x to the n? So the general case of the power rule. We have to use definition of derivative. I know, but I'm honestly skeptical about playing music on stream and about even other voices just because of how the terms of service is nowadays on Twitch. And I'm not certain on how YouTube will take it. Because this whole thing with these people with just even a quick excerpt. Okay. This quick excerpt of other people's streams or something can get copy striked, and it's just like, why? Definition of derivative. we're going to use the definition of derivative to get the power rule. Okay, so the definition of derivative is the limit as h goes to 0, f of x plus h minus f of x over h. Okay, so now we gotta plug that in. Let's see if I can remember. Well, there was some tricks that had to do with it. I know I wrote it down in my notebook. If I can find it, because I've got several of them. But I probably don't have it anywhere nearby. So we'll just figure it out. So we're going to plug in x plus h in for x to the n. Which is, so we've got the limit. So that I'm just going to short form lim. H goes to 0 of x plus h to the power of n. And minus x to the n all over h. Now, this is hard to simplify. What do we got to do? So we're gonna figure out by taking out one factor. Try that. Is that what we gotta do? Take out one factor? Oh man, I wish I remember. I'm gonna look. There's one thing using sums that I don't remember. Just not off the top of my head, obviously. That's what it was. Okay. A plus b to the power of n is actually equal to a sum from k starting at 0 to n of n choose k of a to the n minus k and b to the k, which is the binomial theorem. So what does this look like in just like a bunch of terms? Got a to the n plus n a to the n minus 1 b plus, there's a bunch of ways to represent the multiplication, the sum. I'll do the next one, which is n times n plus 1 over 2, a to the n minus 2, and b to the square plus dot 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 plus n a b n minus 1 plus b to the n. Okay, this is what we're going to use. So we've got the limit as h goes to 0, or approaches 0, I should say. And we're going to write out this binomial in these terms. We've got x to the n plus nx to the n minus 1 times h. We've got plus n times n plus 1 over 2 times x to the n minus 2 times h squared plus dot dot dot. I'm going to continue writing this on the next line. N times x to the h to the n minus 1 and plus h to the n. And then, because I ran out of line, this is still going to be like this, and we have a minus x to the n, and this is still all over h. Now, this x to the n and this x to the n can cancel out, because here's a 1 and a minus 1, so we'll cancel that out. So then we're left with the limit as h goes to 0. Oh, I'm on just the right line. We've got n x to the n minus 1 times h plus n times n minus 1 over 2 x to the n minus 2 h squared plus dot 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 n x h to the n minus 1 plus h to the n divided by h. So from here we can just cancel out 1h on each value, right? So let's just cross out. There's 1. That becomes, there's a minus 1. This just becomes n minus 1. I wrote an n for some reason. And then we can take the limit. But let's write it out again so it's clear. H approaches 0. N x n minus 1 plus n times n plus 1 over 2. X to the n minus 2 h plus dot 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 plus n x h n minus 2 right, yeah, plus h to the n minus 1. And if we have h approach 0, this becomes 0, this becomes 0, this becomes 0, because they all have a multiplication onto h, and we're left with n times x to the n minus 1, which is the power rule. Haha. Cool. Cool, cool, cool. Cool, 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 cool. Cool, cool, cool. What else? Honestly, I'll check and see if there's any requests. It doesn't seem like there is. And there's a weird comment. Okay, well, it's not bad. Should we do another one like this? Although I did do the definition of derivative ones for some post-it notes. I didn't really want to do this one for a post-it note because it's a little bit lengthy. Like from here down to there, especially with all these terms you got to write in. Thanks, Summon. Much appreciated. What should we do next? I don't really know. I feel awkward just going through the beginning of calculus over and over again for no reason, you know? I don't mind it if somebody's actually learning it. Could go through inequalities. Could go through absolute value practice. Yeah. Coordinate geometry. Graphs. What should we do? Let's see. What would be something that's not a post-it note? Did I do tangents and velocities? I don't remember now. I don't think I did do tangents. Nice. Okay. Tangents. Although I am just on a big tangent, aren't I? Time is it anyways? You know, I think that's gonna be it for tonight. Tomorrow will be a different story. I really wanted to start a lot earlier today, but the kid I started tutoring had some major problems and ended up delaying it quite a bit. So I wanted to stop by about now before and just start a whole lot earlier. But we'll see what goes on tomorrow. Nice, but thanks for coming. I do appreciate it so much. The fact that it helps with viewers and time and all that stuff, it makes a huge difference. It's nice to know that people actually want this to succeed besides myself. It's been fun. It's been not bad. Hopefully within the next, I'll say month, because school's starting up soon. Hopefully within the next month I can get some regular kids that I'll just have tutoring fairly frequently, just on stream, because I'd like to have it so that we'll do a call in Discord but stream it, so that they can send me a picture of their homework and I can talk to them directly. They'll mute the stream and we'll tutor them live and we'll go through their homework. That's what I'd really like to get doing, is just having people to talk to, the group, the conversation, because that way I don't explain things, I get them to work on it and they learn better. Honestly, I could explain things for hours and you could not learn anything. Especially when it came to graphing. It was one of those things. Anyways, thanks guys, it's been awesome. I will talk to you probably tomorrow. Is there somebody we should host? Let's see if we should find someone to host. Who wants to be hosted? I'll find someone with low viewers. Let's see. Let's do. Well, let's see who's live. Let's do KM Giggles. He's another streamer from nearby that's pretty low. Perfect. All right, guys. I will talk to you later. Have a good one.